In this video, we are going to discuss the chemical properties of Halo Arenes. These are the chemical properties given: nucleophilic substitution, Wurtz Fittiq, electrophilic substitution, reduction, Grignard reagent. First, we will take nucleophilic substitution reaction. So, you have Halo Arene where you have a CX bond, and this CX bond is very short and strong, and this benzene ring is a source of high electron rich center. That is why the nucleophilic substitution will not easily take place under normal temperature and pressure. This is what we have discussed in the last video. But when you use a drastic conditions like high temperature and pressure, the nucleophilic substitution will take place. So we have given one example also. You take chlorobenzene on treatment with sodium hydroxide at 350 degrees Celsius, a high temperature, and 300 atmospheric pressure, a high pressure we are using, so that the nucleophile OH minus that will attack this benzene ring, and this chlorine will be removed, and you will be getting the product, that is a benzene ring where chlorine is removed and substituted with this nucleophile, that is OH, and you are getting byproduct as NaCl. Here because you have Na plus and OH minus, so this OH minus acts as a nucleophile. It gets substituted in the place of chlorine, so you are getting this product, and this is what we call it as phenol. So you are getting phenol from chlorobenzene and sodium chloride when you use a very high temperature and very high pressure. So this is an example for nucleophilic substitution reaction, and this reaction is also called as Dow's process. One more example you can take. So you take chlorobenzene. When on treatment with ammonia, so ammonia you take 2 molecules, NH3, NH3, you take 2 molecules. When you use a very high temperature, for example 250 degrees Celsius and 50 atmospheric pressure, when you use this ammonia, which has a lone pair of electron, acts as a nucleophile, and this nucleophile attacks this benzene ring, and there is a removal of this chlorine. So you will be getting the product NH2. So NH2 is substituted in the place of chlorine, and the byproduct is this NH3 combines with one hydrogen, NH4 it will become, now combines with this chlorine to form NH4Cl. So you are getting ammonium chloride as the byproduct. And here this NH2 gets substituted in the benzene ring, and this is what we call it as aminobenzene, or otherwise called as aniline. So aniline you are getting from chlorobenzene on treatment with ammonia, which acts as a nucleophile at very high temperature, 250 degrees Celsius and 50 atmospheric pressure. So now next one example, you take chlorobenzene on treatment with cuprous cyanide, that is CuCN, cuprous cyanide at 250 degrees Celsius in the presence of pyridine as a catalyst. Here the Cn minus, which acts as a nucleophile, attacks this benzene ring, and there is a removal of this chlorine. So you will be getting Cn gets substituted in the benzene ring in the place of chlorine, and you will be getting CuCl, cuprous chloride. So this is what we call it as phenyl cyanide. So phenyl cyanide is obtained from chlorobenzene on treatment with cuprous cyanide. So these are the examples of nucleophilic substitution reaction. Under normal condition, nucleophilic substitution is not possible because the bond between carbon and halogen is very short and strong, and this benzene ring is in a center of high electron rich. So a nucleophile cannot attack this. Next we'll go to Wurtz Fittiq reaction. So here you are taking a chlorobenzene C6H5Cl on treatment with sodium and alkyl chloride in the presence of ether solution. So you take 2 sodium and this chlorine, sodium and this chlorine, they will combine to form 2 sodium chloride, and remaining we have C6H5R. So you are getting C6H5R, that is we are getting alkyl benzene. So this is what we call it as Wurtz Fittiq reaction. You take an example. So you take C6H5Cl on treatment with 2 molecules of sodium, and instead of R you take C2H5Cl. In the presence of ether solution, you will be getting this chlorine and this sodium and this chlorine. They will combine to form 2 molecules of sodium chloride, and you have now C6H5, C2H5. So this C2H5 and C6H5, and this is what we call it as ethyl benzene. So instead of ethyl chloride, if you take methyl chloride, you will be getting C6H5CH3. So that is we call it as toluene, methyl benzene or toluene. So this is what we call it as Wurtz Fittiq reaction. Next we will go to Fittiq reaction. So according to Fittiq reaction, you have to take chlorobenzene on treatment with sodium and another chlorobenzene. So you have to take 2 molecules of chlorobenzene on treatment with sodium in dry ether. So you take 2 molecules of sodium here. So this chlorine and sodium and this chlorine, they will combine to form sodium chloride, and remaining you have C6H5 and C6H5 and 2 molecules of sodium chloride. So this is what we call it as biphenyl. So when you take chlorobenzene and chlorobenzene with sodium and ether, you will be getting biphenyl. This is Fittiq reaction. In Wurtz Fittiq reaction, we are taking an alkyl halide and aryl halide. And here only aryl halide we are taking. There is a main difference between Wurtz Fittiq and Fittiq reaction. So biphenyl structure you will have like this. So you take this as one C6H5 and then another C6H5 you will have like this. So the structure of biphenyl is this one. So this is one C6H5. So this is about Wurtz Fittiq and Fittiq reaction. Next video we will do electrophilic substitution reaction. Thank you for watching.